Specimen clamping and hardness testing is a tried and true technique with a long history of success. While it's been around for years, the full range of its benefits isn't always immediately obvious. In this video, we'll take a closer look at how clamping enhances the accuracy, efficiency and safety of hardness testing and why it remains a valuable method in today's testing environments. In clamped hardness testing, the specimen is secured between the test head and the support table throughout the entire test. This is more effective than using a vise, which can slow down the process and introduce handling issues. Hardness testers that allow that kind of method have some kind of clamping device on the test head that holds down the specimen firmly against the table or fixture. The indenter should be positioned near these hold-down devices, and all test movements, such as making the indent and switching to lenses, happens while the specimen is still clamped. The hold-down device should be easily removable for unclamped testing when needed. Clamping improves measurement accuracy by keeping the specimen stable during the test, preventing movements that could distort the results. For example, in Rockwell test, any movement of the sample affects the measurement precision, especially if dirt or oil is present beneath the specimen. Clamping minimizes these issues, ensuring more precise readings. It also protects the sensitive indenter. The clamping fixture surrounds the indenter, preventing accidental damage, especially when working with heavy parts. This reduces costs and avoids inaccurate movements due to unnoticed damage of the tip of the indenter. Another benefit is that clamping creates a defined stop point, making it easier to position the specimen at the optimal working height. This speeds up the testing process and reduces the risk of errors. In production environment, this is especially useful for operators with minimal training, as it eliminates the need of precise manual positioning. This factor is more important when working with heavy hand wheels, which are more convenient and faster in adjusting for different sample sizes. In this case, the defined stop avoids damage to the indenter or the measurement system, which can occur with machines that do not support clamping. But of course, there are still some limitations. Clamping applies significant additional force to the specimen, which may not be suitable for every specimen, for example, embedded ones. It's important to evaluate each case individually. For hardness comparison tests on test blocks, the reference indent must not be clamped. So it's mandatory that a hardness tester can do both clamped and unclamped tests. Finally, we can say that clamping and hardness testing offers clear advantages, including better accuracy, efficiency and safety. These benefits are especially important in production environments, making clamp testing the preferred method whenever it's possible.